Hi. I noticed that the crowd's a little bit larger than it was earlier. I assume that's because you came to see me and not because of the dinner. Jeff asked me to give you guys an update on what's going on in the realm of GPUs, and with particular emphasis on GPUs usage in vision and in artificial intelligence. And the short answer is a lot's been going on. But to get there, I want to give you a little background on where we've come from with GPUs and why they are so good at some of the things that they've been used for these days. He wouldn't let me put up anything about our comics, so it's as close as I can get. But anyway, we chase the pixel. Been doing that for a long time, and we write reports about it. And you can visit our webpage if you want any more information. But if you want to know something about GPUs, how many units have been shipped, how much it costs, blah, 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 where to go, we're the guys that do that. So this symbolizes basic concept of a GPU. And the SIMD, the similar instruction multiple data, that's the parallel processor that is in a GPU. You hear them referred to as shaders. So you'll hear a GPU defined as having 3,000 shaders or 2,000 shaders or what have you. That's what they're talking about. They're talking about a 32-bit floating point processor, and they have thousands of 32-bit floating point processors in the GPU. It's kind of mind-boggling to think about that when you hear about an 8-core CPU, and here is a 3,000-core processor. The term GPU came out simultaneously almost from two companies. 3D Labs developed a GPU, which was a geometry processing unit. It was multi-chip. And a year later, NVIDIA came out with a fully integrated GPU. And so NVIDIA takes credit for the term GPU in terms of G standing for graphics. And we agree with that. The two companies also had two different directions in what their interest was. 3D Labs was going towards the professional graphics side, and NVIDIA entered the market originally and still does a very good business of it on the gaming side. But as you'll see, they kind of all came together at the end. So the GPU has been remarkably extensible, and that's due to a variety of reasons. But in addition to just having parallel processors there, it quickly became apparent that we needed a few extra things. And I should take one step back. I get a little ahead of myself here. Why do we have all these parallel processors? Is because if you think about, say, an HD screen, that's 2 million pixels on the screen. And I want you to remember that number, 2 million pixels, 2 megapixels. And those pixels get updated 30 to 60 times a second. So now do the math, and you can understand that we're doing a lot of parallel processing just to put up a simple picture of an HD screen. And that's the reason that we went to this parallel processing architecture. But we still needed more things to round out the picture. And so we were able to do image processing. It was great doing image processing and video. We then did photo and video processing and video editing, and then simulation and visualization. And to do that, we started adding little state machines, matrix math for color lookup table manipulations and color balancing, video codecs for encoding and decoding, transcoding. And the GPU was the transcoding king for a very, very long time. So it just kept showing that the GPU was nice and extensible. And one of the other great features about a GPU is it has a private local memory. And it's a very high-speed private local memory, and it's a very large private local memory. So that meant that the GPU could do a lot of things independent of the CPU or anything else. And that was another reason why we kept putting extra engines inside the GPU, so to take advantage of that local memory and its independent processing.